Hi TKG Army, good night to all of you. And we already derived the expression of magnetic field due to a straight current carrying conductor with the help of Biot-Savart law. Now today we will derive, this is our lecture number 3 for your magnetic effect of current chapter, and in this lecture we will derive the expression of magnetic field at the center of a circular current carrying loop. And this one also derived with the help of Biot-Savart law. All of you know the expression of Biot-Savart law, dB is equal to mu naught by 4 pi I del L sin theta by R square. This is the expression of magnetic field due to a current element dl. So for this case, at first you consider a circle, draw a circle, and suppose this circle has radius named as R. R is the radius of the circle and current I is flowing in this direction, clockwise. Okay. So first of all, for finding magnetic field at the center of this circle, at first you have to find the magnetic field due to a small current element. Then we will find out the total for total current for total circular wire. Okay, so first of all you consider a small current element del L. Suppose this value is del L and the direction of del L is always along the direction of current, and in that case this one will be along the tangent, along the direction of current, and this one will be the tangential. Yes, so this is the direction of del L, and you see this is the value of R, this is the radius, this point is center. So we already completed this part. This is the value of del L and you find out the value of P here. This angle is theta. So at this point the expression of magnetic field, that is equal to I del L sin theta by R square into mu naught by 4 pi. So first of all you write this one. Consider a circular loop of radius R carrying current I. Now the entire loop can be divided into a large number of small current element, del L, del L, del L. Like this way the total, we will find out the total magnetic field for this entire loop. So first of all you find the magnetic field due to this del L portion at the center O. So write it according to Biot-Savart law. According to Biot-Savart law, magnetic field at O due to current element del L vector, that is named as dV vector, and you write it in magnitude form, and the formula is mu naught by 4 pi I del L sin theta divided by R square. Now question is, what is theta? Theta is the angle between del L and R. Theta is the angle between del L and R. Now here you find out the value of theta according to this condition. Del L is directed tangentially in the upward direction and this one is the direction of R. So this angle obviously 90 degree perpendicular to each other. So here you find, putting this value, that is this one will be mu naught by 4 pi I del L sin 90 divided by R square. So this value will be dB, that is equal to mu naught by 4 pi and I del L and the value of sin theta, that is 1. So this one is the value of dB, mu naught by 4 pi I del L by R square, and this is the expression of magnetic field at the center of this circular current carrying loop. Now you see, and this is the expression for this current element del L. Now if we consider the del L at this point, and that point del L direction is also perpendicular, and this is the value of R, here also theta, that is 90 degree. So the result expression will be same, the magnitude value will be same. Now if we consider the del L at this point, the direction of del L here, and this is the value of R, so the angle theta here also 90 degree. So at that point, if we consider del L, the expression of magnetic field will be same. Similarly, if we consider del L here, del L, this is the direction of del L and this is R, so this angle is also 90 degree. So for every small current element del L, here the magnitude value of del B, that is equal. Now you see what is the direction of magnetic field here. You use, this is the direction of del L and this is the direction of R. Direction of R. Now use right hand palm rule. This is the direction of current. So use this finger like this way. So now you see the other finger direction. Other finger direction. The direction of other finger, that is inward. So at origin O, at the center, the direction of magnetic field is into the plane of the paper. In same way, if we consider this del L, now you use your finger like this way. This right hand, this is the direction of current, this is the direction of current. Now you curl your finger like this way. So at that point also the direction of magnetic field, that is into the plane of the paper. So at every point the direction of magnetic field, that is into the plane of the paper. So here direction is represented as cross, okay, at every point. So this is the magnitude value and the direction into the plane of the paper, right? If we write direction, that is into the plane of the paper, into the plane of the paper. Now you have to find out the magnetic field for entire current loop. So if we add del L, del L, del L, del L like this way, then we will find out the total magnetic field, and there is a way out. We have to integrate. If we integrate this dB value, then we will easily find out the total magnetic field. So write it down. Now total magnetic field at O, and that is B is equal to, we will find out this value by integrating dV. Now integrate, that is mu naught by 4 pi I del L by R square. Now you see here there is a del L, there is integration with respect to L. So you have to use limit. So the lower limit is 0 and upper limit for total circular loop. Here if we consider the total length of the wire, that is L, so 0 to L. Now you see the constant part, mu naught I by 4 pi R square, constant. So this one will be outside, mu naught I by 4 pi R square, constant, that is integration 0 to L del L. Now integrate. So B will be mu naught I by 4 pi R square, the integration of del L, that is L, you know the integration of dx, that is x. So this one is 0 to L. Now putting the value, mu naught I by 4 pi R square, L minus of 0, that is L. You can write L. Now use, what is the value of L? L is the length of this circular current carrying loop and the length of this wire. So the length of the wire, that means the circumference. So radius R, so the circumference of the wire, that is obviously 2 pi R. So here the value of L, that is 2 pi R. So now simplify it, pi pi cancel out, 2 cancel out, R cancel out. So the expression of magnetic field, that is mu naught I by 2R, is important for a numerical purpose, for your theoretical purpose. So at the center of a circular current carrying loop, the expression of magnetic field, that is mu naught I divided by 2R, where I is the current flowing through the wire and R is the radius of that circular loop, okay, and the direction, that is into the plane of the paper. Now you have to remember this formula. By remembering this formula, you can easily find out the expression of magnetic field when this one is semicircle, when this one is quadrant. So for this shape, we can easily find out the expression of magnetic field, you have to remember one thing, that is at the center of the circular current carrying loop, magnetic field expression mu naught I divided by 2R. Okay, so now we will find out the expression of magnetic field at the semicircle. You see, this is semicircle and you have to find out the magnetic field here. So for semicircle, this part is same. Now you integrate, integration, that is integration del L, that means L, and there, so there will be B, that is equal to mu naught I by 4 pi r square, and the value of L, that is integration L, and this value for semicircle will be what? The length of the semicircle, that means circumference half, circumference value, that is 2 pi r, so this one will be 2 pi r divided by 2, so 2 cancel out, pi cancel out, so this value will be 1 r cancel out, that is mu naught I upon 4 pi r. So this is the expression of magnetic field at the center of a semicircle. Simple. For length, for circular loop, in the place of length you have to use 2 pi r, for semicircle you have to use pi r, because this is semicircle. Now if we find out the expression of magnetic field for this quadrant, what will be the answer? Same method. At first you have to find out dB, you consider here del L, current is flowing this direction, this is del L, and for this del L, and this is R, this is perpendicular 90 degree, so at first you write dB, then dB is equal to this one, then after that you differentiate, integrate this one, that is B equal to integration dB, and in the place of L, here you have to write, you see, that is B equal to mu naught I divided by 4 pi r square, and in the place of L you have to write what? This is a quadrant, 1/4 the circumference, that is 2 pi r, so here this value L will be 2 pi r divided by 4, so this one is 2, so this result will be pi cancel out, 1 r cancel out, that is mu naught I divided by 8 r. You see, so this is the general formula. Now with the help of this equation you can easily find out the magnetic field for semicircle, for quadrant, like that, and this part is important. Okay, now you see one general concept, you can take a screenshot, one general concept here. You can easily find out the magnetic field for any angle. You see, when angle 2 pi, the formula of magnetic field, that is mu naught I divided by 2r. For circular loop, the total angle, that is 2 pi. So for 2 pi angle, this one is mu naught I divided by 2r. So obviously for angle 1, that is 1 rad, this one will be mu naught I divided by 2r multiple of 1 by 2 pi, divide by 2 pi. Now for any angle theta, the answer will be, you see, for any angle theta, for 1 rad, this one is mu naught I by 2 pi into 1 by pi. So for theta, this one will be mu naught I by 2r, theta divided by 2 pi. You remember this formula. For any angle theta, the expression of magnetic field at the center, that is mu naught I by 2r into theta by 2 pi. Now use simple concept. For circular loop, theta is 2 pi. So if we use theta, that is equal to 2 pi, you see the expression mu naught I divided by 2r, 2 pi cancel out. So this is the expression of magnetic field for a circular loop. Now for semicircle, what is the value of theta? For semicircle, the theta will be 2 pi divided by 2, that is pi. Now you use here pi. And then C, the value of B, mu naught I divided by 2R. This one is pi by 2 pi. Pi divided by 2 pi. Pi cancel out. So the answer will be mu naught I by 4R. You can easily find out the value of magnetic field for a semicircle. In same way, for a quadrant, what is the value of theta? That is 2 pi divided by 4. Obviously, quadrant 1/4 of the circle. So, and the answer must be this one. You use, if theta is equal to 2 pi by 4, that is for quadrant, then use this general formula. B is equal to mu naught I divided by 2R. In the place of theta, you write 2 pi by 4, 2 pi by 4, and there is 2 pi. So 2 pi cancel out. So this one is mu naught I divided by 8R. You see, the expression is same. The expression is same. So the general formula, that is for 2 pi, angle is mu naught, value is mu naught I by 2R. For 1, mu naught I by 2R divided by 2 pi. So for theta, the value will be mu naught I divided by 2R divided into theta by pi. Suppose you have to find out for 30 degree. So what will be the answer? You use 30 here? No. You have to convert 30 in radian. Or you can say another, you can use another concept, that is 2 pi, that is 360. If we use 30 here you have to write 360. If you use 2 pi here, then you have to convert theta, you have to convert this 30 degree into radian, and you know the conversion, that is pi by 180 into 30. This is the concept. Now here you use, in the place of theta, that is this value, then you can easily find out the expression, the value of magnetic field for the angle theta is equal to 30 degree. So this is the main theoretical concept for this class, students. Now we will check 2 or 3 numericals related to this problem. Okay, chalo. See problem 1. A helium nucleus is completing one round of a circle of radius 0.8 in 2 seconds. Time given, radius given, and the nucleus name, that is helium. Show that the magnetic field at the center of the circle, that is 10 to the power minus 19 into mu naught Tesla, and you have to take E value given, the value of E given. Okay, write it. So for helium, what is the charge? You know, 2He4 is a helium, and the charge of helium, charge, that is 2 into E. Now you have to find out at the center magnetic field, and we already derived at the center the magnetic field, that is mu naught I divided by 2R. So write it here, mu naught I divided by 2R. Now R given, but what is the value of I here? So you know the basic formula of I, that is equal to Q by T. Here one complete rotation, that means T must be time period, and in the place of charge, here you have to use the charge of helium, that is 2E. So I, that is equal to 2E divided by capital T. Here T is represent the time period for a complete rotation time. So the value of B will be mu naught 2E divided by 2R into T. So here 2 cancel out, so the result is mu naught, and the value of E, put it this one, 1.6 into 10 to the power minus 19, that is the value of electron. R, that is given 0.8, and T, that is given 2. So 2 0.8, that is exactly equal to 1.6. So you see answer already there, that is B is equal to 10 to the minus 19 into mu naught, and the unit of B, that is Tesla. Okay, now see problem 1. Write down first. This types of problem is very important, students, for your exam purpose. Okay, and the logic is very simple. You just think. So read it. Problem 2, which value is given and where you have to find out the magnetic field. The figure given, this is the figure, and you have to find out the magnetic field at the center O due to this total wire. Now here you see a long wire having a semicircular loop of radius r carries a current I. You have to find out the magnetic field at the entire wire at this point O. You see, this is PQ, state current carrying wire. This is ST, state current carrying wire, and this is QRS, is the semicircle. So you find magnetic field at point O in three parts. At first you find for PQ, then for QRS, then for ST. Okay, find it. So for PQ, you just see here PQ, that means this is the value of del L. This in this direction is represent del L along the direction of current, and you have to find out the magnetic field at this point. So this is the value of R, this is the R. Now see the angle between del L and R. Here del L is directed along x-axis and R is also directed along same way. So the direction between del L, that is the angle between del L and R, is 0. So you know the formula, Biot-Savart law, that is dV is equal to mu naught by 4 pi I del L sin theta divided by R square. Now here theta, mu naught by 4 pi I del L sin 0 degree divided by R square. So this value is 0. Suppose this is dV for PQ, write it for PQ. So for PQ, the value of dV, that is 0. Why 0? The angle between del L and R here 0. You see, this one is del L, this one is R. So both are in same direction, that is angle 0. Now for QRS, that is for semicircle, write it. So for second case, for QRS, that is semicircle, and you already completed this part, students. For circular loop expression, that is mu naught I divided by 2R. So for semicircle, the expression, that is mu naught I divided by 2R into half. This one, dB for QRS, that is mu naught I divided by 2R for magnetic field total current carrying loop. For circular part, for semicircle, this one will be half. We already derived this part. So this value will be mu naught I divided by 4R. Now third case, that is for ST. So write down for ST. Now you observe one another point, that is for ST, this is the direction of current, this is the direction of current. So this will be the value of del L. Del L is directed this way, and here R is directed that side. Here R, this is the R, the value of R, opposite direction. Del L positive x-axis, R negative x-axis. So this angle, the angle between del L and R, what? 180 degree. So write it. So this value will be dV for ST, that is mu naught by 4 pi I del L sin 180 divided by R square. So the value of sin 180, that is also 0. So this value is gives 0. For straight line, you use the general formula Biot-Savart law, and for circular loop we already derived that the center, that is mu naught I divided by 2R. So for semicircle, this one will be half into mu naught I by 2R, that is mu naught I by 4R. So for the entire wire, what is the value of magnetic field? 0 plus this one plus this one. So the total magnetic field, total B, that is mu naught I divided by 2R. And what is the direction? You see, this is del L, this side, this is R. So the direction will be, use this hand, this one is the direction of current. So this will be going inward. So here direction, that is inward into the plane of the paper, into the plane of the paper. Okay. Now see, third one is more interesting. The figure given carries a current of 10 ampere, current value given, and you have to calculate the value of magnetic field at the center O, this point. The radius of the coil, the value of given, that is 3 centimeter. Here you see, this is not a semicircle. this is semicircle, so you know the value of L, but here you have to find out the value of L, the integration. You see, in previous part we just completed integration del L, so in the place of del L, integration part, that is L, so here you have to find out the value of L. So write it down first. So for problem 3, at first you have to find out the value of L. Now see, in question this value is given 90 and total angle, that is total rotation 360. So obviously what is the value of this angle? What will be the value? So write down problem 3. At first you have to find out theta. So theta is equal to, you know the formula, basic formula, arc by radius. Now you use what is the value of theta here. This angle is 90, that is pi by 2. Total angle, that is 360, that means 2 pi. So obviously this angle will be 2 pi minus pi by 2. So this value will be 3 pi by 2. So in the place of theta you use 3 pi by 2. Arc is named as L, that is length, and this one L, and radius, suppose this radius R. So here L is equal to 3 pi R by 2. Now use the general formula, B is equal to mu naught I divided by 4 pi R square and integration 0 to L dl. The basic formula, you see, mu naught I divided by 4 pi R square, integration 0 to L into dl. So mu naught I divided by 4 pi R square dl, that means L, 0 to L, is mu naught I divided by 4 pi R square. This one is L minus 0, so L, and the value of L, this one 3 pi R by 2. This is the important part. Here you have to find out the value of L. So in the place of L you use 3 pi R by 2. Now pi cancel out, 1 R cancel out. So this one is mu naught I, 3 mu naught I divided by 3 mu naught I divided by 8 R. Okay, now putting the value, see, 3 mu naught, that is 4 pi into 10 to the power minus 7. The value of I, that is given 10 and 8, and this value is R, which value given? R, 3 centimeter, that is 3 into 10 to the power minus 2. See, this 3 cancel out, 10 to the power minus 2, 10 to the power minus 2, when this one will be upward, that is 10 to the power plus 2, 10 to the power plus 2 plus 1, that is plus 3, that is 10 to the power minus 7. So this value will be, see, this cancel out, that is pi by 2, and this value is 10 to the power plus 3 minus 7, so that is 10 to the power minus 4 at the Tesla. So this is the answer. And what is the value of this portion? What is the magnetic field for this current carrying conductor at this point? 0, because this is the direction of del L and this is R. What is the value of for this wire? Also at this point result 0, because this is also straight. This is the direction of del L and here R, angle 180. And in that case the del L direction that side and R is also that side, so both are in the same direction. Theta is equal to 0 degree. Just previous case, for straight wire the result 0. For one case, that is theta 0 degree, that's why 0. For another case, for this case, result angle 180 degree, so answer is also 0. And for this part, at first you have to find out the value of L using this formula, then you use the basic concept. Okay, I think this part is clear to all of you students. And now go back to your exercise book, solve the problem, tell me if there is any problem. Today I am ending here. Bye bye.